Yeah, as you have said before, my background is our digital infrastructure projects. The last recent was the Infomix project, which we were coordinating. And even if I tried to have a more wider focus in this presentation, it will be centered around this infrastructure vehicle topics. Yeah. Since Austratech is a 100% subsidiary of the Austrian Federal Ministry of Climate Action, Environment, Innovation and Technology, yeah, it's also, I think in this presentation, quite a lot of this public authority view. Okay, so I will start with a more general slide on the developments taking place currently. I know they have been dealt with in more detail in other sessions, but in order to give the relation to this digital infrastructure topic later on, I still would like to spend a few moments on it. So I think, yeah, there are several different developments which are very dynamic and lead to several new opportunities, but also to risks. And yeah, we have new services such as MaaS, which have been discussed yesterday, but also this all this sharing, robotaxis, shuttles, and so on. And this is one new field opening up. Another area is that digital infrastructure gives us new measures to interact with single vehicles, but also with fleets to steer traffic. And that this includes also, or can include also, hub management, which would be very important for intermodal application. This can include geofencing applications as well, which are very suitable for such management activities. And what is very important here from my point of view is that this interaction can be carried out independently of the location, which is significantly different to conventional signage, be it static signage or dynamic variable message signs. And yeah, it allows us, as said, to carry out management in a new way. Then another very important field opening up new possibilities are automated vehicles, for example, when they complement public transport. But these automated vehicles also lead to new challenges, such as mixed traffic conditions, which need to be addressed. We did this specifically in Infomix, and I will have some slides later on. Also, the capabilities of vehicles are increased and make them safer, and options as teleoperations allow to extend the field of application, the operational design domain. And of course, the overall demand is expected to increase significantly. So the situation changes for sure. And the question here is, in which direction should the mobility system evolve? What is the goal? And what are the desired characteristics of the mobility systems, which then has a very high influence on the requirements towards digital infrastructure. So I think there are several characteristics which are desirable. I have listed some of them on this slide. So safe, clean, affordable, efficient, accessible, but there are, of course, many more. Obviously, these characteristics are not independent from each other, and there are links between them so that they influence each other in a complex way. I would say that there are even some elements which are in some ways contradictory. What is also obvious is that, at least from the current point of view, it's not possible to have a transport system with all these properties at the same time. I guess there is no disagreement that all these characteristics are important, but if all of them cannot be realized at the same time, for example, due to available budget or available technology, prioritization has to be carried out. And when it comes to prioritization, the question is, from my point of view, I would expect that priorities will be different depending on who is asked, be it policy representatives, operators, service providers, end users, or companies in the logistics area, for example. Of course, there will be similar views, but I would expect that there are also substantial differences, to some extent, of course, even within one stakeholder group. So coordination between these elements is a key element from my point of view, and it's important to avoid negative effects. And it's also necessary to be able to unlock the potential of new mobility solutions. For example, when digital infrastructure enables automated vehicles to extend their ODD and therefore to be able to complement public transport solutions. Due to the technical developments and also due to developments in society, I think even these interdependencies are not fixed. And I think, and yeah, due to the fact that these are not fixed, I think also this coordination and all the digital infrastructure activities have to be carried out in a very flexible and adaptive way. So I expect that that this flexible coordination is a key element to achieve a good future transport system. And as said, digital infrastructure is a key element that this coordination can be carried out. So digital infrastructure in some way is required to be able to realize this desired impact of new solutions towards safety, towards network efficiency and environment. And this digital infrastructure should allow us to get out most of this possibility and to reach goals, even if they are contradictory in some way. One example would be that digital infrastructure allows measures to be taken in a very targeted way, for example, by reducing maximum speed only in situations where it's really needed, and therefore increase situations in increase safety in these situations, but without reducing efficiency too much. And with this, I would say minimum measures, also increasing the acceptance of the measures itself. So this was just one example. And on the next slide, I have listed some areas where digital infrastructure could contribute. Of course, as said in the beginning, mainly centered around this infrastructure vehicle area. So I think there is, of course, traffic management, addressing different aspects as steering traffic according to policy priorities, increasing safety, and also supporting to achieve a clean system or increasing efficiency. I would say that traffic management, at least also having this Infomix perspective in mind, is currently a core element for digital infrastructure. And I would guess it's also of high importance in future, since I think there will always be some road infrastructure that needs to be managed in a good way. Going one step further, we have, of course, mobility management. And I think here it's very important to integrate the new services in the transport system in a good way. So I have mentioned before hub management at intermodal hubs. I think that there are also important applications towards mass interaction with fleet management, which would give great opportunities from my point of view. And I think this could even go as far as setting service level agreements in a dynamic way. Digital infrastructure, as I have mentioned before, also facilitates new solutions and services, for example, by closing ODD gaps, for example, on strategic important locations or stretches. And digital infrastructure can, of course, also increase safety by supporting or complementing vehicle sensors. Of course, there are some other or many other aspects of digital infrastructure, as well as payment, reservation, maintenance, validation, and so on. It's clear that this list is not complete, but what I would like to show with it is that there are different applications and that there are huge differences between these areas. And this leads also to different requirements towards the infrastructure. So what is required from the digital infrastructure in terms of quality, security, availability, performance, privacy, and more differs substantially on these areas. So to obtain concrete solutions, I think we need to look into concrete examples and at the same time try to be as general as possible to be able to use synergies. On the following slides, I would like to present the status in some of these areas based on different European projects and platforms. But first of all, I would like to start with what is already there, what is going to be deployed. And this is CITS. It's available and it's going to be deployed. The direct communication between infrastructure and vehicles is a core element of several use cases and services. And in the C-Roads platform, authorities and road operators are working together and harmonizing the deployment activities of cooperative intelligent transport systems across Europe. And the goal is to achieve interoperable cross-border CITS services. Also, vehicles are available commercially already. So, for example, different vehicles from Volkswagen can be ordered with CITS on board. Also, on the infrastructure side, deployment is carried out. One example is the Austrian motorway operator ASFINAG, which has started deployment of more than 500 roadside units and of a central control unit in November last year. On the next slide, I have put a map which shows the current CITS stations in Europe. So we can see that there are really a lot of activities going on. When going directly on this map via the link I also put on the slide, it's also possible to see which messages are disseminated by these roadside stations, and also if they are in test mode or not. On the next slide, I would like to show the different services deployed within C-Roads. So in order to get an overview of what is addressed. And what we can see here is that there are both areas, the motorway area, but also the city area is addressed. And we have a wide variety of these services, starting with warnings about hazardous locations, via the very important area roadworks warning, to in-vehicle signage and intersection applications. And these services are very useful both for human drivers, but also for automated vehicles. They have the potential to extend the operational design domains of vehicles and therefore enabling new services. One example would be the information of traffic lights, which could be used to complement the sensor information of the vehicle and therefore have enough redundancy for driving over the vehicle. Or I know also applications where in projects where vehicles are relying fully on this information on traffic light status by electronic messages. These messages can also help automated vehicles to see if the conditions on the road ahead are outside of the ODD of the vehicles, and therefore the vehicles can then decide to make a timely handover and increase traffic efficiency and also reduce safety critical situations. And particularly the intersection use cases with traffic light prioritization, they are also very relevant for public transport applications. In order to show what are the key working and discussion areas in this CITS area, I've listed the current C-Roads working groups on the next slide. And this shows that the technical discussions are centered around security, service harmonization, hybrid communication, but also around testing and validation. Another very important element, of course, for all digital infrastructure activities is what is the benefit. So also the topics of evaluation and assessment are addressed by the C-Roads platform. I've also mentioned before that there are several use cases for urban applications. And while in the first phase of the C-Roads project, or of the C-Roads platform, it was centered more around motorway applications, even if there have been some traffic light use cases there. Now in the second phase, there is really also a big focus on this urban use cases. So I would say CITS has arrived in the cities. So after this quick view on deployment activities, I would like to go more in the direction of future applications. And here I will start with the Infomix project. Yeah. As a brief summary, the Infomix project could show that road infrastructure can support and improve efficiency and safety of the transport system. In this project, amongst others, several traffic management measures have been developed to increase safety and efficiency in mixed traffic environments with both automated and non-automated vehicles on the road. The Infomix project itself has focused on the motorway environment, and the work was done on the basis of 3 key scenarios. The first one was to dynamically dedicate the lane to automated vehicles to improve safety in mixed traffic environments. The second scenario were roadwork zones, which are key areas concerning road safety. And the third group of scenarios are bottlenecks, for which measures have been developed to improve efficiency. And here, 3 different controllers have been developed. One was a controller for recommendations for ACC parameter adaptations. Another one was lane change advice, and a third one was mainstream traffic flow control via variable speed limits. The vehicles have been addressed by digital and physical means. For the digital communication, both the Wi-Fi based ITSG5 and cellular communications have been used. A big part of of the evaluation was done via simulations because, of course, we had not enough automated vehicles on the roads to show this effect. And these simulations have shown that an increasing penetration rate of automated vehicles will lead to a decrease of traffic efficiencies if no measures are taken, such as also simulations of other projects have shown. The simulations have shown that there is a positive impact of safety for the developed speed recommendations. The developed ACC time gap controller could improve efficiency in case of delays up to some 50%, and this would work even for low RSU coverage. And speed advices could decrease delay times by some 10 to 15%. It has been shown that the positive effect on efficiency could be achieved with about 15 to 20% of communication-capable vehicles only, because they influence the whole traffic with their adapted behavior. So this works even with a low coverage of, for example, VMS for addressing conventional vehicles. Concerning the traffic estimators, which were also developed in the project to provide the information to the traffic management center, which is needed to trigger these measures. These traffic estimators, particularly a cross-lane estimator, has reached maturity for immediate exploitation, and this estimator works with also with data from vehicles. And this allows the reduction of the number of required spot sensors, and therefore also a reduction of costs. Other projects like also the Horizon 2020 funded Transaid successfully developed solutions for addressing this transition of control situations. And this shows that this shows the high potential of digital infrastructure support and also the importance of this support in mixed traffic situations. So we have seen that there are a lot of different possibilities for infrastructure support of automated vehicles. What is important as well is to know which kind of support is available. In the Inframix project, therefore, the ISAT classes have been defined. This is a classification scheme which shows the support of infrastructure for vehicles in 5 different classes from E to A, where class E refers to conventional infrastructure with no support for automated vehicles, and class A to very high support with including cooperative driving functions and dynamic guidance. So when the capabilities of certain stretches to support vehicles are known, this allows the vehicles to select the route accordingly, so that the route includes very long and continuous areas where they can drive automatically. In addition, such a scheme is also a guide for public administrations and road operators to guide their investment and to target their activities on strategically important elements. What is important here is, what is important here is that such a scheme is agreed on European or even higher level, since national differences would make it difficult for the vehicle side. Of course, such an ISAT class can change dynamically, for example, due to bad weather conditions. And a challenge in this area is also that such a downgrade of an ISAT level might be different for different vehicles depending on their sensor capabilities. Another application area which is very or where infrastructure, digital infrastructure can contribute is linking traffic management with mobility service providers. This is a focus of the TM 2.0 platform, which is aiming at convergence of mobility service and traffic management. The right side of this slide shows needed interaction between the different stakeholders, which are road infrastructure owners, content service providers, roadside service providers, in-car service providers, and service consumers. And depending on the implementation, of course, one entity can cover different roles. The aim is to create synergies between actions of individual travelers with the collective mobility objectives, and to create giving value and creating new business opportunities with this. What is also important here is to find a way to exchange data in a way to create benefits for all, and at the same time guarantee privacy and the interests of the involved parties. This figure shows as well the importance to distinguish between different roles and the complexity of the system. When it comes to different roles, another project has looked into it in a very much detail, and this was the SEDER-funded Ryzen project. And the goal of this project was to assist national road authorities in identifying how digitalization and automated driving developments will affect operations and interaction with other stakeholders. The project focused on the 3 key use cases, which were provision of high-definition maps for automated mobility, the distribution of digital traffic regulations, and infrastructure support for cooperative automated driving. So the Ryzen elaborated in detail processes for these 3 use cases, and this slide shows a flow chart for the distribution of digital traffic regulations, which will be a key application from my point of view, and which have been I think on this slide we see that there are several different steps and also different options to realize the distribution of digital traffic regulations. And this is similar also for the 2 other scenarios. A key element in realizing these use cases is therefore the collaboration between the involved stakeholders. And the core step is to agree on a common vision and also on the role. And this is a difficult task due to differences in roles, processes, and also in technical status in different countries, but also between different road types. Another important aspect, specifically related to the distribution of digital traffic regulations, shown on this slide, are quality and security mechanisms to ensure that the information on which the vehicles rely on are correct. Of course, as well, the interfaces have to be agreed on and implemented. This use case is also a good example that even for those use cases where responsibility seems to be rather clear, when looking from a higher level, when looking into the details, there are several aspects which need to be clarified. And this is also a good example for the complexity of the topic, highlighting again the need for collaboration and a common view. And I will now come to my last slide. Yeah, as stated in the beginning, for me, it's very clear that digital infrastructure will be the key or a key enabler for future mobility solutions. As a short summary, cooperation and coordination is essential for a sustainable future mobility system, and digital infrastructure is a key element for several different applications in the transport systems by opening up new ways of direct interaction. Key elements like CITS for interactions with users are already available. Digital infrastructure allows to achieve goals in an efficient way by allowing very targeted measures, and so to avoid other negative effects in other areas as much as possible. What is, of course, essential for the further development is to develop a common view on goals and on KPIs to be able to assess the effects of the measures. And it's very important to be able to find out the cost benefits, since this will define what will be finally implemented. And here it's important to look from a level which is high enough to consider the value digital infrastructure brings to the applications, which then bring the value to the users. Yeah. Finally, I think this flexibility towards different priorities is a very important element. And also the capability to deal with the several uncertainties which are there, technical development and other developments. And this has to be considered in the design of solutions. What is also very important is to consider, and a key challenge is to consider the long lifetime of infrastructure equipment. So I would like to thank you very much for your attention, and I'm open now for questions.
Thank you very much for this very comprehensive presentation that gave us a really nice view about ongoing and important activities in Europe. So have you got, are there any questions? Please do not hesitate to ask them on the chat or also orally if you want. Ah, yeah, there's the first question coming by Adam. Thank you very much for the talk. My question, how can we improve the flexibility of coordination within the mobility digital infrastructure interface? Is the lack of flexibility primarily due to limitations in the technological solutions or management ones?
Yeah, that's a very good question. I think also a difficult question. So I would say on the one side, there is, of course, the need of standardization, so that to agree on how infrastructure and vehicles can interact, and this is yeah, goes in a very, very detailed level. And I've been in this in discussions. I'm not directly involved in standardizations, but with different projects I was involved in, I've seen that when it comes to the point on what are really the single fields, then it's yeah, it's very complex and different and difficult. And then on the one hand, we need to have this. On the other hand, we have to be open with the architecture, which what is allowed by this. And so it's I would say on the one side it's technological. Also considering what technology is able to deliver now and what it will be in future. But I think the bigger problem is the management problem, to be clear on what has to be managed and how should it be managed. In the InfraMix project, for example, we have used mainly CITS messages, which we have extended for communicating with vehicles. But of course, the more we come to a general level, to a mobility management, I think the more difficult it will get.
Thanks for this answer. Are there any further questions for Martin here? What was the support by the policymakers for this?
I think the role of the policymakers is, or I would like to maybe to approach from a different way. On the one side, it's important to show the possibilities of infrastructure to the policymakers, and on the other hand is to involve them. So I think there's quite a lot of interest from the policy area, and I think also, yeah, what is needed is to find ways to experiment and to learn and to try things out. And this was one aspect of the very interesting presentation before by Katja, where she highlighted this regulatory strategies for innovation and dealing with uncertainties. And I think this is also this clarification of possibilities and ways to show these interdependencies and between these different goals. This would be very important also to learn in future.
Follow up. There is a follow-up question from Katja. What level policymakers were involved? EU national ministries, specific groups in the ministries?
I would say in the Inframix project, we had different stakeholders, and here we had a focus on the road operators. But I would say in the Ryzen, they also addressed a wider area of policy stakeholders, also from ministries and so on. I am afraid I have not very much more information on this. What I can say is in Inframix, of course, we have involved also the organizations of road operators, and have also been, for example, in for the definition of these ISAT classes, we have been in close contact with AirTrack, so it's also in the AirTrack roadmap. Yeah.
Okay, thank you. There is now a question by Edgar. Thank you for the talk. Do you think this vision of infrastructure support can be implemented in different zones besides highway and with other types of vehicles besides AV?
Yes, I think this classification should be transferred also to urban areas, because I think it's a key element to know which infrastructure is where. So also for decision on what are the strategic points. And I think there are also interesting projects which investigated the how current infrastructure is suited for automated vehicles, such as I think it's called Avenue 21 project. They did this for Vienna and showed, with very interesting results showing that in the inner city, the streets are not that suitable for automated vehicles, but in other areas they are. So I think it would be very important. And concerning the second part of the question, to what other types of vehicles beside AVs, I think it could be also very relevant for in order to see how drivers of conventional vehicles could be addressed. And of course, it would be relevant also for vehicles which are automated, but I would say not this classic form of vehicles, but shuttles or maybe even some. I have not thought about it, but maybe it could also be interesting for some pods in the logistic area, maybe.
Thank you, Martin. And now looking at the time, I think we should now end our session, the first session of this morning, and we now go to a 13-minute break because I would like to come back punctually at 11:15 for our podium discussion. So please, let's meet again at 11:15 for our roundtable.
Thank you very much.
Thank you, everyone. Thank you, Martin, very much again.
Thank you.